Hello, it's Jay here again and welcome to another tutorial. So, in this lesson we're actually going to work on the wheel movement so that the wheels rotate and in the correct direction depending on whether we are going forward or reversing, and also turn for the steering. So this will probably take more than one video, and as always we'll begin with the variables because we cannot do anything else till we've got those in place. So I'm going to create of type public game object underscore front left wheel and close the line off. Now, a word of note here, I could have done these as an array and have them all moving, but because I'm aware that you will all be using different models, I'm going to move them individually, and I'll explain. I was testing this with a model where on one side of the vehicle I had to rotate the wheels 180 degrees for them to actually be correct on the vehicle, which obviously means that they're moving in opposite directions on one side to the other. So doing it this way will mean that it should work on any game model that you are using. So with that said, let's put in a comment, and it's going to be the usual: create slot in inspector to assign front left wheel, and with that we can copy this line, and I'm sure you've guessed what is coming next. We're going to paste it in 3 times, and we're going to change the next one to front right, and the next one to rear left, and of course I'm altering the comments as we go, and the last one to rear right. So we'll just change the comments for this last one, and I'm going to copy the first 2 lines. So the front wheel lines, and we're going to change wheel to hub. And on this one as well. Remembering, of course, to change the comment. So these 4 variables exist for the wheel rotation, and these 2 are for the steering. And of course, if you're using, let's say, a 6-wheel vehicle or maybe even an 8, this will still work. You just need to create the extra variables. And once we actually get round to implementing how the steering works, it should be easy enough if you want 4-wheel steering as well in your vehicle, which I know is uncommon, but there are vehicles that do have that. So let's come below, and we're going to create of type, we will make it public so we can see it in the inspector, but you can go ahead and make this private once we actually finish testing this script out. Public float RPM wheel. So into the comments, defines naming convention for the RPM of the wheels, and in fact we can make the others private, providing we can see the RPM in the inspector. It should mean that the other 2 are working correctly. So we'll create a type private float underscore, and we'll say wheel diameter. close that line off into the comments. So we'll say it defines the wheel diameter, private float, and we'll say wheel circumference, and close that line off into the comments. Defines the wheel circumference. So let me explain these three variables. This is so we actually have a smooth speed up to the rotation of the wheels and a somewhat realistic rotation as well. Now, a word of note, it's impossible to be 100% realistic straight off the bat. And I say this because it will depend on your terrain, the vehicle you're using, and the scales that all these models are using as well. But what this should do is give you a very, very good starting position, and hopefully then you can tweak it as needed. So below, I've typed private pool and excuse me, we'll give it a naming convention of underscore moving forward into the comments. Defines if we are moving forward, and I'm sure you've guessed we're just going to copy and paste that line and change forward to backward. And again, we'll save that off there for the moment. So we create these bools just so we can adjust the direction of the rotation of the wheels, depending if we're moving forward or backwards, so that the rotation is always in the correct direction. So, and I've just got a little typo there I'll fix. We don't need one for idle. These two will be more than enough for us. So let's come to the void awake and we'll set these up. So we'll say wheel diameter is going to be equal, and yeah, I'll just use the rear right wheel. Now, obviously, it doesn't matter which wheel you use, because the chances are that all the wheels are going to be the same size. However, if you do have a vehicle that has larger wheels on the rear, let's say to the front, that's absolutely fine. You just need to repeat this line and choose one front wheel and one rear wheel. So it's just a case of repeating the line and choosing one of each size. So we'll say dot transform dot, and let's use local scale dot x, close that line off into the comments, and we'll say wheel diameter equals wheel, I'll just put scale on x axis. And we'll say underscore the wheel circumference is going to be equal to the wheel diameter times pi. And we do that by saying times mathf dot pi. And we'll close the line off. So wheel circumference equals the wheel diameter times pi. And I'll put this in the void start actually. can go anywhere in the void start. We'll just say that the moving forward is equal to false. Close that line off into the comments. So we'll say moving forward equals false on start up. And I'm sure you've guessed we're just going to do the same for the moving backwards. So let's copy and paste that in there. Moving backward equals false on startup. So let's save this off. So we've got all the variables that we need in place. We're defining the wheel circumference by getting the diameter based on the wheel's local scale, and then times in that diameter by pi to get the wheel circumference. We're setting these two to false. And in the next lesson, we'll pick this straight up and we'll work on calculating the RPM and actually the wheel movement itself. So I think we'll leave it here for now. Oh well, in fact, let's just go ahead and create that function before we leave. Let's come down to the bottom. We'll say private void wheel movement, open and close brackets, open and close again. Let's just copy a debug line. Let's paste that in and swap out the naming convention. And also let's copy that twice. And we'll just add forward to 1 and backwards to the other naming convention. So there we go, wheel movement forward, wheel movement backwards. So let's save that off there. So these functions are ready to be filled out now. And in the very next video, that's, as I said, that's what we'll do, and actually get all the code for the wheel movement in place. So as always, I hope you enjoyed this lesson. I hope to see you next time. And until then, as always, bye for now.